We are absolutely swimming in data. It's everywhere, in our businesses, on our phones. I mean, it's just part of life now. But here's the crazy part. Even with all this information around us, getting a straight answer to a simple question like, hey, which marketing campaign brought us the most new customers last quarter? Well, that can be a real headache. We have all the data, but the question is, how do you actually talk to it? Yeah, so why is it so tough? Why can't we just, ask a database a question in plain English and get an answer? That's really the core problem we're going to dig into. It's this fascinating puzzle that sits right where our human language bumps up against cold, hard machine logic. Okay, so think about it like this. Imagine your database is a massive, giant library. It's got every single fact and figure you could possibly dream of. But, and this is a big but, the librarian who runs the whole place, they only understand this super strict, kind of secret language called SQL. If you don't speak that language perfectly, you get zip. Nothing. And you can see that disconnect right here. On the left, that's what the super strict librarian needs. A really complex SQL query full of all these specific commands and syntax. But on the right, that's what we as humans actually want to ask. Something simple like, which model saves the most gasoline? That gap between those two worlds, it's huge. But, what if there was a way to bridge that gap? What if we had some kind of universal translator? A piece of tech that could take our simple, everyday questions and, on the fly, convert them into the complex language that the librarian understands. Well, that's exactly the promise behind a technology called text-to-SQL. So how does this magic translator actually pull it off? How does it work? All right, let's peek behind the curtain a little bit and look at the process an AI follows to turn your question into a precise query the machine can understand. Well, it really boils down to four main steps. First, the AI has to really understand what you're asking, just like a person would. Second, it connects the dots between your question and the library's card catalog, what we call the database schema, to figure out which books or tables have the answer you're looking for. Third, it writes out that perfect request in SQL. And finally, it hands that request over to the database to run the query and bring back your info. Okay, and there's always a but, right? This translator, it's powerful for sure, but it's not perfect. Sometimes it just gets the translation flat out wrong. And when it messes up, the results can be anything from a simple error message to, and this is the scary part, a totally misleading answer. Usually, the problems fall into one of four big buckets. First up, you've got AI hallucinations, where the AI just makes stuff up. Then there's schema confusion, where it basically gets lost in the library. You can also run into performance issues, where it writes a query that's so clunky it slows everything way down. And then there's the big one, security risks. So, what on earth is an AI hallucination when we're talking about this stuff? It's basically when the AI just makes things up, but with total confidence. It's like it's trying to grab a book from a shelf that isn't even there, or looking for a chapter that was never written. The query it writes might look right, but it's based on pure fiction. And this chart here, it's great. It really breaks down what these mistakes actually look like in the real world. You have system errors, which are kind of like typos. Value errors are when it uses the wrong term. But look at the big one. The most common by far are skeleton errors. And these are the real problem. We're talking fundamental logic mistakes in the actual structure of the request itself. So, to fight this, researchers came up with this framework that's basically a quality control loop. First, the AI spits out the SQL query. Then, a special step tries to identify any errors. And if it finds one, it kicks off a correction step to fix it. This whole cycle is the key to making this technology something you can actually rely on. So, how do we actually put this quality control into practice? Well, the first big idea is to make the translator itself smarter. It's all about teaching the AI to double-check its own work before it even dares to talk to that strict librarian. Okay, so one of the smartest ways to do this is to just give the AI a better map of the library. Instead of a basic card catalog, we give it something called a knowledge graph. Think of it as a super detailed map that doesn't just show what books are there, but how they're all connected, what the chapters mean. It just gives so much more context, which really helps cut down on the confusion. And the second big technique, we let the AI learn from its own mistakes, like right as they happen. It's called an execution-driven feedback loop. Just imagine our translator tries out a sentence, sees the confused look on the librarian's face, that's the error message, and then immediately tries a different way of saying it based on that feedback. So let's walk through this loop. Step 1. The AI gives it its best shot and generates that first SQL query. But, oops, this first try has a mistake in it. So the database tries to run it, but it fails, and it sends back an error message. Now, this isn't actually a failure. It's really, really important feedback. It tells the AI exactly what part of its translation didn't make sense. And this is the cool part. The AI takes that very specific feedback, looks again at the original question and the library map, and then generates a new corrected query. This little self-correction loop can happen over and over until it gets it right, all without a human having to step in. It's pretty amazing. So making the AI smarter, that's awesome, but it's only half the story. We also need another equally critical strategy. We have to build a safer environment for it to operate in. We have to build guardrails to make sure that even if a mistake does slip through, it can't cause any real harm. And that brings us to a really, really critical idea, summed up perfectly in this quote. We have to treat every single piece of code that an AI generates as if it came from a totally untrusted user. You just can't trust it blindly and let it run wild. Okay, so what does that mean in practice? It means you need a security checklist, and it's non-negotiable. First, you give the AI read-only access. That way, it can never delete or change data. Then, you validate every query to block anything that looks fishy. You have to automatically mask sensitive data, enforce user roles so the AI can't see things it's not supposed to, and finally, you keep a detailed log of everything it does. These aren't just good ideas, they're essential. So when you put it all together, you've got a smarter AI working inside these strong, safe guardrails. We start getting much closer to the ultimate goal here, having a real, natural conversation with our data. And it's just wild to think about how far this tech has come. We started with these clunky, rule-based systems back in the 2000s. Then we got more flexible, deep learning models. And then, boom, pre-trained models like BERT changed the game. And now we're in the era of these massive large language models like GPT-4. The speed of progress here is just mind-blowing. And through all of this, the goal has stayed the same: democratize data, to knock down that wall that separates the experts who can speak SQL from everyone else who just has a question they need an answer to. The whole point is to make talking to a giant database feel as easy as just talking to a person. And all this leads to one last big idea to think about. For so long, the questions we could ask were limited by whether someone knew how to write the code. But as that barrier just melts away, and pretty soon anyone can ask anything, what new, more creative, more profound questions are we going to ask?